Okay, I'm going to continue tutorial 7, but before I get started, I will remove the sum code that I added last time for explanation, because as you can see here, it will introduce errors. Yeah, we can fix this by like something like this. The problem with this is in fact because we didn't declare the header in the header file. Okay, so what I can do, first of all, okay, I can remove this left. Okay, so you can use the convention naming set and get. Here we can have, I think, value, and then yeah, this one. Okay, for now we don't have to add this, unless later on if we need to have that method, then we add later. Okay, we can add later, because I want to move quickly to the next task. What else we need? Okay, this one, I think, do we have? Okay, let's try to compile this first. Okay, some other errors, I think this the same goes. The error comes from, okay, this one I forgot to. Then what else? I think we also have this error. Okay, again, this is for explanation last time, so I can simply remove this and then try to compile it again. Okay, and see. Okay, we still have errors. See out. Yeah, this coming from here. So again, I can remove this. So in your case, what you can do, you can use the original code base, okay, meaning that the fresh one that I uploaded to elearning, so that you don't have these errors. Okay, we are going to start from the original code, because from task 1 to task 4 is all about explanation. We don't have to add any code, because the tasks have been the answer for the task have been given in the code. Okay, let me try to make sure everything is working before we get started. Okay, it's supposed to be working. Okay, now let's move on to next task. Task number 3. Okay, task number 3. This is actually, I think we have done this. Yeah, we have done this from previous class. Get right, get top. Okay, we need to provide some convenient methods, okay, to make later on to make our coding much more convenient and then much easier. Okay, so because the information about the location of the ball only the center, right? So we can introduce a calculated or derived field, or derived quote unquote derived attribute for the left, for the right, bottom, and top. Okay, by the way, I need to mention here regarding the coordinate system that we are using in WinBGI. Okay, assume this is the screen. Okay, let's assume okay, this is our screen. Let's assume this is our screen. So the 0, 0 is here. Okay, so positive x go to the right and positive y go to the bottom. Okay, so you need to take note on that. The coordinate system, most the graphic system are using this kind of coordinate system. It's slightly different from the Cartesian system that you are familiar with in mathematics. Okay, so I believe we have done this. Yeah, we have the ball get left, get right. Yeah, we have done this. Okay, last time I also showed you my preference regarding writing the set and getter, the setter and getter. But in here, if you want to use the convention one, you may do so as well. Okay, so for the sake of this tutorial, we are going to use the convention one, which is get left, set left, and so on. Okay, I think task number 3 has been done. Okay, so but what you need to do for this task number 3 is only to review the code and then try to understand what the code is doing. Okay, so we have done here actually. Okay, for the get left, we have get x, get y, set x, set y as well. We have the oh, this one is point. No, this one, the ball. Okay, we have get location, get right. Okay, I can simply write in this way. Okay, to make it okay, so that they use only one line. So we can introduce several convenient methods. Okay, something like this. So we are going to use the get right and also get left later on for testing whether the ball hits the wall. Okay, now I think we can move on to task number 4. Okay, task number 4, okay, again task number 4 has also been given. So what you need to do is just to go to the code and then try to review the code, try to understand what the code is doing. So basically task number 4 is about the classroom. Okay, so how we implement this room. The room again has the location. Okay, normally when you create object that based on graphic output, you need to have these three kinds of attributes. The first one is about attribute about location. Okay, so like just now we have ball, right? The location is about the center, but for room, the location we use the this corner, the top left corner, to represent the location of the object, the room, because we can position the room anywhere inside the screen. Okay, one type of attributes is the location, something to do with the location. The second one is about the size. Okay, just now for the ball, the size is the radius, but for this room, the size is the dimension, width, and also the height of this room. Okay, the third one is about the presentation, the appearance, like color, the outline. Okay, the outline color, fill in color. Okay, you can have, if you have font, then the font color, font type, and so on. That's all. So you need to have these three categories of attributes when dealing with graphical objects. Normally in your project, you are going to have these three types of attributes. Okay, so let's move on to the code for the classroom. Okay, I already opened classroom. I need to bring here the nice here. Where is the classroom? Yeah, this one. Okay, so for the classroom, there is nothing unusual here. It's the structure actually almost the same like the ball. The only different things is about later on is about the method. There is no fancy method here like the ball. In the ball, you have to provide move, right? But for the room, you don't have to make the room move. So we simply what we have here are simply methods that deals with the attribute here. Okay, the setter and getters. But as well, you also need to have the drawing. Okay, this is very important to have draw. So let's take a look what the code is doing here. Okay, yeah, the structure is all about the same. So I can simply I prefer to write in single line. Yeah, make it just a single line. Okay, the rest is about the same, and then this one. Okay, for the drawing. Okay, here we don't have undraw because we don't in this example we don't simulate a room that can move. Okay, but you actually if you want to create that kind of room, you can also add the undraw method. Okay, but for simplicity we simply just draw the room. Okay, so here we deal with the fill color. That's why we use set fill style, and then to draw a box, use bar. Okay, if you use rectangle, it only draws an outline rectangle. Okay, and then and then the outline is always white unless you set the outline with set color. Okay, I think we're done with this. Okay, again, you can also, because we in the storage, I mean the attribute, the core attribute is x and y for the location. Again, you can introduce a combination method, several combination method, like to get the right, to get the left, bottom, and so on. Okay, this is very important for this case because later on, if you want to test out whether the ball hits the left, so how do you know the left location? So you need to have this information, the left. Yeah, again, you can actually do it without the convenient method get left or get right. Oh yeah, this one is right. But if you don't this convenient method, so every time you want to test out the ball hits the right side, then you need to do calculation every time you want to test out. Okay, you need to compare this x plus with. Okay, that's why it's a good idea to introduce convenient method to get the right side of the room. Okay, then okay, we move on to task number 5. Okay, so now task number 5, you go to task number 5, just review to task the main function. Okay, let me try run this again. Okay, by the way, first of all, before you start run, choose multi-file graphic project, and then you can start run. You're supposed to be getting the code base supposed to be give you this one. Okay, a circle that moves from left to right. Okay, so let's take a look the structure of the main function. Okay, again, as I mentioned from last class. Okay, this is actually the structure of the program that you are going to use for your project. Okay, so the structure is actually there is nothing unusual. This is similar from what you learned from PT1. Okay, the only difference here is that we have this special loop. This is what called the main loop. Okay, the main loop is the place where you put all your manipulation on the object, like the moving you put here. Okay, last time I showed you the trick how to make several objects do the action looks like simultaneously. Okay, the trick is use only one single loop. Okay, and then you put everything inside, and then you don't do any loop here. You don't do any loop. Okay, you might be thinking, okay, since I have multiple objects, then I need to create a loop here. It can be another loop here for that kind of cases whereby you have a list. Instead of using one single object, you might be having a list of an array of objects. So that kind you use loop only to iterate, because you don't want to write something like b0.move, b1.move, b2.move, and so on. Instead of having that kind of code, you replace with for I equal to 1 until how many objects you have. That one is okay. However, you don't write any loop that something else from that kind of iteration. Okay, so for example, like here maybe you want, okay, you want to do something like what I can show you here. I don't have a very good example for this one. Integer equal to 0. Okay, and you try to do something like, okay, something like this. Maybe you want, let's say you have okay, maybe I can maybe I can give you an example. Let's say you have two objects here, b1 and b2. Let's pretend we have b2, and then b2 also move, right? And b1 also move. Let's say you want to achieve something like, okay, I want b1 move 3 times. Okay, 3 times, but b2 only move once. So you can simply write something like that. b1 first move, second move, third move. Okay, 3 times. So this one can be replaced with a loop, right? Okay, you are going something like that. Okay, so for each iteration, b1 will move 3 times, but b2 moves only once. Let's say this is your intention. Okay, this is your goal. I'm not really recommend you to do this because you are trying to use a loop inside this loop. Okay, if you want this kind of, let's say this is your intention, what is the reason of moving 3 times? You might be thinking that you want b1 to be moving 3 times faster, right? Something like that. So in order to achieve that, you don't do that. You only move once, but what you can do, you change the speed, the attribute speed of b1, rather than you run a loop for 3 times. Okay, just now I was mentioning you only actually want to use loop here for the case of something like, okay, let's say we have array which contain 5 elements. Okay, so let's say we have balls I dot move. This one is okay, because if you don't use loop here, so you will be writing something like 0 move, 1 move, 2 move, right? So this is actually the reason we have here, because the reason we have a for loop here is just to make it our code dry. You don't repeat the same thing here, but we simply loop. Okay, this is supposed to be fine if you want to use loop inside this loop, but try to avoid using another loop here. Okay, again, if you have a function, maybe you run a loop inside move, try to avoid that, because we want to make sure all objects get attention fairly. Okay, because we try to mimic like the multi-threading here basically. So if you can replace the iteration behavior by using counter variable. Okay, like just now we are talking about, we want b1 to move 3 times faster than b2. You don't write 3 times move, you don't call 3 times move. Instead, use an attribute. You might be calling the attribute as a speed. Every time you move, you increase by the speed. speed. So in order to make B1 move 3 times faster than B2, then you make the speed 3 times larger than the speed of B2. Okay, that's the trick. Okay, you don't try to avoid using loop inside the code, inside the method. Okay, the reason is because you don't want that object hold the focus of execution, because if you use for or any kind of loop, the operation will block that loop will block the operation. So let's say the loop is done inside, let's say in the move. Okay, the B1 move, but B2 will stop because the focus now is on B1. Okay, that's why we try to avoid using loop in the method. Okay, it doesn't basically violate the OOP principle. However, this is just to make sure we can achieve the asynchronous execution, or asynchronous execution, or non-blocking execution. So that's the reason. Okay, now we back here. This is the right. As you can see here, when we move, we don't really care about where to move, how far we need to move. Why is that? Because all the information already set here. Already we set here during the creation. Okay, last time I believe I had mentioned that in order to deal with object runtime, normally this is the operation. You create object, you insert by instantiation, and then you initialize to provide the information. Because later on when you manipulate, you don't need to tell how to do things. I mean, like to move, let's say if you want to move the object, you don't tell the object, okay, you move 5 times, because the information already given during the initialization. This is very important. Okay, so in something like this, okay, B1 dot move, we don't tell B1 how far it should move here. Okay, we no longer need to tell you, because we already tell this object, this is your attribute. I believe this one, right, the 51. You move by 50 to the right. Okay, so that one is what you want to learn about this main CPP is about the structure of the code. Okay, this is very important. You need to have the main loop. You put everything here. Okay, so we have B1. Let's say if I have another B2 here, I can introduce B2. Okay, and then the point, let's say we start from the this is from the middle, right? So yeah, let's say, and then but the speed is to the left. Let's try this. Move horizontally as well, and then again I set here, but here I simply move B2. Okay, so here I also need to start drawing it first. This is to draw the room. You must make sure the room is there, just to just for the output, to draw the room, draw the ball, and then you start manipulate here. Okay, let's try to run this. Yeah, because the room starting from here, that's why you don't see. I think I need to change the location. Let's say location, we start from the screen width. Okay, in the middle. Okay, again this one I'm going to start from the middle, screen width in the middle. Okay, and then let's try the other one is red, so they are going back, and then I want to put the second ball a little bit down below, which is, let's say we add with 100. Okay, let's try to run this. Yeah, as you can see, we have two balls. They are executing at the same time. Looks like it at the same time, but what happened basically, we do or sort of like round robin. Okay, every time the iteration, the main loop iterate, it keeps the execution one part to ball 1, the other part to ball 2, and so on. Okay, so this is very important. If you want to change this into loop, then you can replace this with an array. Okay, so but for now we are not focusing on that. Okay, so let's move on. Okay, task number 6. Okay, task number 6 is about the implementation of aggregation. This line. Okay, we implement the aggregation between ball and room. So in this case, we must use aggregation here because the room are shared between balls. Okay, meaning that 2 or more balls can be in the same room. Okay, so that's why we and then the ball doesn't own the room. Okay? Again, also the room doesn't own the ball. Okay, so we use aggregation, and then the implementation later on, you put the room declaration inside the ball, because the ball needs to know about the room, right? Because the player here are the balls. They are, every time you move, okay, because we are going to do manipulation later inside the main loop. As you can see here, we are dealing with balls, so every time the ball moves, it needs to know the information about the room, so later on it can decide whether it can know whether it hits the room or not. Okay, so that's why we need to provide information about the room, okay, by associating it to the ball, something like this. So as you can see here, we use a pointer. Okay, we use a pointer. So let's take a look. We go to the room. Now we go to the ball, this one. Okay, we have here. Okay. Yeah, we need to add here the ball. Okay, we need to add here. Okay, so we can add ball, not ball, but this is a room, and then we can use the same variable room. Okay, now since we are calling a room, now let's try to compile this first. Okay, when we compile this, of course we get an error because the compiler doesn't know what room is all about. Okay, so in this case we need to include information about the room. Okay, because classroom is inside room. Okay, inside room as room HPP. Okay, when we compile this, we're supposed to be yeah, we're supposed to be fine. Okay, the definition is supposed to be fine. Okay, just now I added a new attribute. Okay, again, it is very important in normally in C++ or OP in C++, when you have attribute, you always want to make sure all the attributes are initialized. Okay, so room here is another attribute. Okay, so let's say okay, so if you don't initialize, most likely C will give us for this variable a random value, which is a random location. So we don't want to have a random location, so then we need to do it here, which is inside the room, right? So inside the ball here. Okay, I can introduce here because this one is the okay, we can actually use here again, use constructor initializer and then make it null. Okay, or I can actually also write this. You can also write this here. The room, initially the room is null. Okay, if you don't specify the room, then okay, so we don't specify here. Okay, although you can also actually specify from here, but if you don't specify, then you need to initialize here. Okay, just now I mentioned about if you have any attribute in your object, make sure the attribute is initialized. Okay, you do that in constructor. If you don't supply the initialized value from parameters, okay, let's say for size, right? Okay, we don't have size here. Okay, what you can do, you still need to initialize size. If you don't know the value, normally you just make it 0 value. Okay, like for number with 0 and so on, string with null string, empty string, and so on. Okay, for pointer, you make it up null. Okay, you can do it in this way, or you can as well use the constructor initializer. Okay, again, since we introduced this okay, we introduce another attribute, which is room. This actually comes after the aggregation relationship, right? Then we need to facilitate this. Okay, just now we just initialize, but how we allow the main function to invoke this? Again, you need to create an interface, which is a method. Okay, I can introduce here. Again, I can call. Okay, let's where should I put? I think let's put it here. Okay, stat room. Okay, and then later on get room, because room is a private member. So what's the type? So the type here is room pointer. Again, you just take from here, get the type room pointer. Okay, and then it's also a constant, just return room. Done. Okay, how about this? This is the same, and then we pass here as a room. Oh, my mistake. This one's you don't write a definition here. Okay, we are going to write in the CPP void room, and then yeah, simply something like that, room. Okay, and then we can take this, we bring this, and then we put inside the ball. Let's say we put it, I think, yeah, let's put it here. and then I can tag this, okay, and then this one something like that, okay, and then this is room, okay. I can simply use the one room underscore room, okay, and then for the getter return room, okay. You need to return a pointer again. It returns a pointer. Okay, so I think we're done for this. Yeah, we add a new methods called get room, set room, and then let's move on to task number 7. Task number 7, we need to modify program. Okay, we need to add this. Okay, so I think let's try to run this first to make sure everything is fine. Okay, the program is running just now, was running just now. Okay, so again, I to follow the slide, so I just need to remove the p2. Okay, just now I was showing you only for example. Okay, now we are going to do this. Okay, for move, okay, let's take a look the move in for the ball. Okay, I can go here, go to definition. Where is it? Go to definition F12, but it opens here. Okay, I don't want to open here, so I can go from here. Okay, no, this one move. Okay, set movement, this one. Okay, so we are going to modify this one. Okay, this only shows that okay, it moves based on the dx and dy. Okay, again, dx dy represent for two things. One is the direction left or right for the x, and for dy up or down, okay, negative or positive, okay, and also the magnitude of movement. Okay, so but here we need to add this one. Okay, we need to, okay, what this code actually is doing, is basically here, what we can interpret here, after we move, we need to test out, we need to check whether the ball hit the room. Okay, so that's why it's very important to just now we introduce this get right or get left. Why is that? Because we want, when do the what we call the collision detection, to test whether the ball hit, we test with the edge, not the center, right? So you can go ahead to type this in your code. Okay, I already added the code here. Okay, the one that you can grab from here, this code. As you can see, we don't have get left. You can actually replace get x with get left and get y with get top. Okay, then if you notice when you run this, we're supposed to be getting runtime error. Okay, let's try to run first. We supposed to be getting runtime error. Okay, see, segmentation fault here. Why is that? Because here, if you can guess here, okay, we compare the get right. This one is supposed to be okay, but this one, okay, let's take a look. The problem with this, I can, first of all, I can debug this. Okay, I put a breakpoint here. You can click on here, or you can simply, you go this line and then press F9. Okay, it will create a breakpoint so that later on we are going to stop at this point. And then I press F5, and then let's take a look. We are going to diagnose what is going on here. Okay, when you look at this, I think we can open. Yeah, you can see here the room. Let me check. Go to watch, see what is room 0x0. This is actually null. That means just now we introduced a pointer room, right? This is actually to this one, right? To tell the ball in which room this ball is in. Okay, so this is just to point the room. However, what we have inside the main function, okay, see, we don't create any link. We have the room one, and then we have the b1, but we don't create a link. So that's why b1, that's why for room here is still null, because we don't associate the room yet. We don't point the ball to any room. So what we need to do, actually, we in the main, okay, we can now start create a link, which is set room. Okay, the room must be a pointer, which is address of room 1. Okay, the address of room 1. Okay, I think what is the color of the room? The color is black. Okay, so we simply use black here, and then I think I need to in order to make the room visible, I think I need to create here a draw a line which is set color, and then otherwise, because we if you run this, we don't see the room because the color is black. I purposely use black because in our undraw for the ball, it draw the background with black. Okay, so set color white. I don't set color white, and then let's create a rectangle. Okay, this is to draw the outline rectangle. Yeah, like that. Okay, let's try to run this. Okay, we stop this and then run it again. Okay, okay, we don't see the, where is it? Yeah, as you can see, it keeps bouncing in. Okay, I think the room is not right. Okay, I need to fix the size of the room. Let me try to figure out it first. Okay, I think my bed was this one. It was my bed. This is a typo. It's supposed to be less than. Okay, one here, less than. Okay, and then the same goes to this, less than or equal to. What else? But just now we didn't see the room, right? So I need to change the room here. Set color white. What's going on here? Okay, for now let's try to just use a outline room. Oh yeah, the room, because the room is we don't see yeah, because the room is the entire screen here. Okay, the entire screen. So I can actually let's make the room slightly smaller so that you can see the result. So here make it maybe divide by 2. No, divide by, yeah, divide by 2. But the ball, we are going to start the ball from not divide by 2. The ball, okay, let's try start from divide by 4. Okay, so let's see. So we have the room, and then it is supposed to be looking something like that. Okay, so as you can see from this, what is it, the logic here, this is actually what we did here. Okay, we can interpret this. Okay, if the ball, the right side of the ball hit the right side of the wall, okay, then change the direction. Okay, change directions by simply change by simply negating the dx, and then again for testing with the left side, you test with the left edge. In fact, this one you can actually combine this condition by using O. Okay, because as you can see here, they are using the same action, which is negate the dx. Okay, you can combine this get right with the second condition with the O operation. Okay, now we're done with this, and then let's move on to task number 8. Task number 8, modify the ball B1 in main B so that it moves in both direction, horizontal and vertical. Yeah, so and then we are going to change the color to blue. Okay, and then okay, let's do this. Okay, let's do this, which is for the ball in the main function. Okay, this one we can, okay, I think I can change this to, let's say this 50, and then for the direction also 50. Okay, and color here, let's change into blue. Okay, you can write color name with color name, or you can simply use this what we call this is the it's not a function, basically just macro. Okay, RGB, so the red is 0, green is 0, but the blue is the maximum 255. Okay, so I prefer to use this one because you have a full control of using colors. Okay, by the way, if you're familiar with the color system, you have this model RGBA, but WinBGI doesn't support the alpha channel, which is you can control the transparency, but WinBGI doesn't support that. This color doesn't support that. Okay, so let's try to run this, then let's see what is the result. So as you can see, so every time it hit the wall, it change the direction. Okay, as you can see, by simply changing a little bit of code, the result can change drastically. I mean, it's not that too complicated to write application that can animate. Okay, now I think we done with task number 8. Okay, oh, but I forgot, I think the color, why the color doesn't change. Let me double check. The color supposed to be the background color supposed to be, oh yeah, because just now for the room I close this one. Okay, so I think I need to open it again. Okay, let's try to run it again. Okay, as you can see what is going on here, we can see the trace. This is coming from the result of undrawing, right? Okay, because when we undraw, okay, the reason we undraw the circle is actually just to mimic the animation, right? You want to show that the object moves to the next location. Before you move that on the screen, you need to clear out the existing circle. The way we did it is basically simply draw the same circle with the background color. But in our implementation, when we go back to the ball, okay, for the drawing, okay, what is it? Yeah, this one, the undrawing. We always draw with black color. Okay? This is only true if you draw on the black room, right? So the trick here to overcome this, we want to draw this circle with the color of the room, so that it will be looking something like, it clear out the existing ball. So in order to do that, that's why it is very important to associate this ball with the room, so that every time the ball needs to know information about the room, it can do that by accessing the pointer and go to the room. Okay, so we fix this. Okay, we fix this by, okay, I can change this with, let's say, back color. Let's say we call it BG. Currently is black, right? This is BG. Okay, but this one we can replace this with get the color of the room. Okay, or I can simply write this directly into the code I put here. Okay, then when we run, you see, as you can see, now it draws with the background color. It draws the background color with color from the room. So that's why how association can be used for this scenario. Okay, you may notice now that actually when you write your code in object oriented, it looks like you communicate the objects through the relationship. Okay, so in general, association is there because one of the most use case for association is to allow an object get information of another object. So for example, for this case, we want the ball knows about the room. So for example, like the color of the room. Why the ball needs to do that? Because later on when it needs to do the undraw, it needs the information about what kind of color I should use, right? Again, the ball also needs to know about the edge or the wall of the room. So that's why you associate this ball to a room. Okay, now, okay, we're done with task 8. Let's move on to task 9. We are going to create another ball B2 and then link it to room number 1, and then task 10, create another room and then create another ball B3. Okay, and then associate to room number 2. Okay, let's do that. So now for the consume, okay, since we already have our classes, the rest of the code is supposed to be straightforward because we just consume the classes. Okay, so in the main function here, we need to create another ball, okay, which is B2. Okay. Let's say we start with the same from the middle of the room, but now this is let's call this like red, okay, right? And then this is slightly slower. Okay, let's make it like 10 and then or whatever here. And this is task number 9. I think we straight away go to task number 10. Create another ball, B3. Okay. Oh, by the way, I forgot. We also need to associate. Okay, again, make sure we associate the ball to a room. Okay, I put into room 1. Okay, for and then this one also B1 dot draw. Okay, B2 dot draw. Okay, okay. So okay, then okay, let's try to run. This is actually task number 9. Okay, I think we can add more. Ball 3, and then the location, let's try to put this into the other side, which is this one is maybe 3/4. No, this one is supposed to be this one. Okay, we can change that later. This one, and then the height is the same, but let's call this string the speed. There you go. And then another room number 2. Room number 2, this is the other side. Okay, we start from, this is the left, this is the top. Okay, so we are going to start from here, okay, with the same size. This is yeah, the size is the same, which is half of the screen, and then the height is also the same. But let's make this as a red room. Okay, before we can okay, and then also the room needs to be drawn first. Okay, so let's draw the room first, B1 and B2. Okay, let's try what's going on. Let's try to run this. Okay, I just know I did typo error. Okay, so that means the room is working. Okay, now we can start drawing the object. Okay, we have the object. Okay, then we assign for room number 3, assign ball number 3 we assign to room number 2, and again here. Okay, again, actually this one actually you can replace this with array. Okay, but for simplicity, for this example, we don't focus on that. Okay, then here, yeah, you can simply replace this with b2 b3. Okay, you're supposed to be looking at this. We have the object. I don't know whether you can see. Okay, there is yeah, it's working perfectly, but we still, as you can see, we still have a little bit problem here, because the ball can move beyond the wall. Okay, and this is because you move first without do the checking. So later on we need to fix that. I think we also need to make the ball move faster. I think it's better to specify the speed. Let's make them a little bit faster. I think 100. So maybe this one is 100 as well, maybe 50 as well. Okay, I think that's fine. Okay, let's try it again. Yeah, but I think I need to change this color, right? Make it white. We already have white here. Okay, maybe I can make ball number 3 to yellow. This is yellow, and then this is white. Okay, yeah, supposed to be okay, but the red one is not. The red one is too fast. I think I need to change. I think 50 is enough for this case. Okay, supposed to be fine for that. Okay, let's move on. So we done with task 9 and task 10. Now there is another problem here, which is task 11. Okay, in task 11, you need okay, if I run the program again, I'm not sure whether the video can pick up the problem here. As you can see here, see, this ball move beyond the wall. Okay, the yellow one beyond the wall. Okay, so we want to fix this. Okay, so this is the scenario. Okay, the ball can move, and then why this happen is that because we test this just now. We have this code, right? We do this after we move. Okay, so what we need to do here, actually we need to do some correction here. Once we move, then we need to do correction. Okay, before we start drawing, just now, because of the drawing, we already draw the object without checking whether the object beyond the wall. So we need to do some correction here. Okay, so this is the correction you can add. Okay, so I'm not going to show you here. I'm not going to show you in the code. You can simply look at from this slide. So we do correction here. So this is before, okay, after we test. This is testing for checking whether the ball hit the wall, and just now we have moved, right? Here the way we did the correction is basically something like I don't have the, yeah, so if the current condition of the ball is beyond, is that it is beyond the wall, you need to adjust the location of the ball such that it will be looking something like this. Okay, so this is the trick how we overcome the problem with what we have just now. So this is what the code implies. Okay, in fact, you don't need to explicitly test, okay, if the wall beyond the wall, because from this calculation it implicitly inside this one, because by having the difference, because if the ball in this condition, that means the difference is 0, right? So you can simply use this. Okay, set the center, meaning that you need to shift if the situation is something like this. Okay, we only do this if the ball hits the wall, meaning that this one, if it is only in this situation, okay, if the wall still keep running from here, we don't apply that condition, because we put the condition inside this condition, we put this correction inside this condition, okay, for the horizontal, something like, okay, if this is the previous one, we don't do anything changes for this, but this is the correction. This is actually what we do, what we are doing here. We shift, okay, here, because we test to the right, meaning that for this condition, okay, the right side, if it is in this condition, then we need to shift the circle, okay, with this difference, okay. I'm not sure whether I can draw from here. We calculate this different, and then currently x is here, right, the center, and then we move this x, okay, a little bit to the left, okay. The amount is the same as this different, okay. And then the result supposed to be looking something like this, okay? The edge is in the wall, okay. So the same goes for the condition if the circle beyond the left side here. You will be doing the same as you can see from the example here, okay. Again, also for the top, okay, if it hits the left side and then beyond the wall, then you need to adjust a little bit to the right side, okay. That's why you need to add with the size, whereby the size this is basically actually you just now, let me do some correction, okay. And you don't actually add with this, but in fact, in order to achieve this condition, what you need to do, you get the location of x, and then you get the location of this guy, which is the wall, and then you minus with the radius of circle, in order to make the circle looks like something. It's just slightly touching the wall, okay. The same goes to this, okay. So it's not about getting the distance here, but in fact we only test whenever the ball hits the wall, we always do this correction, okay. That means, because the condition that the ball hit the wall, there are several situations. It can be exactly touching the wall, or slightly beyond the wall, or maybe beyond the wall, something like that. But whatever the case is, we always do correction, so that at the end the result will be looking something like this one. The ball is always slightly touching the wall. So that's this line implies, okay. This is for the right side, this is for the left side, this is for, I think this one is for the bottom side, okay. This is the correction. That's how you do it, okay. I think that's all you need to do, okay. I think let me complete this, the code, okay. So we simply do here, okay, and then location, we set x, okay. We only set the x, and then first of all, get the room, the right side of the room, and then we minus with the ball radius. Okay, this one is supposed to be, I just need to copy this, okay. Set x, then get this one is get right, and then we have get left. Oh no, there is no left yet, but it is x, and then plus, okay. And then for y, okay, this one is location, set y, get bottom minus size, then get bottom plus size, okay. Let's try this out. I think we still have problem here. I think I need to check again the code. I think I did something wrong on my code, okay, my bad. Okay, this one we don't have, this one is supposed to be get y, okay? And then here is the get bottom. I think that's one we missed just now. Okay, let me try to run it again. Yeah, still there is a problem, okay. Okay, I think that the same goes to the left, okay. Get left, this is supposed to be okay, but this one get right, for the get right, okay, this is okay, but this one get x, Okay, this one is supposed to be set X, not set Y. Okay, double check again. Okay, it's supposed to be working now. Okay, yeah, it's supposed to be working. Okay. Okay, the tutorial is supposed to be done, but I will add a little bit more to refactor this code such that we are going to use an array. Okay, so I will convert this into an array. So first of all, maybe the room as well, we're going to add array room. Let's call this rooms, and then we have two rooms, and then the first room something like this, and then we simply tag this one room one. Okay, we're done with that. And then room number two, this is room number two. Okay, so we can remove this. So the same goes to balls, and then let's make it three balls here. And then I can create initializer called the constructor. I don't need to explain regarding the syntax, right? So just straightforward. Okay, this is how we write the constructor if you want to initialize an element of an array. Okay, so since we have our object now in array, so we can simply use loop. Okay, the room, only two room. Okay, so I don't, in fact, I don't like to use constant value. So instead of using constant fixed literal value, we can number of room n. Okay, let's call it n room, which is an integer. Okay, so this is 2, so we can simply use n room here. So the same goes to n ball. This is 3. Okay, so we can replace this with n ball. Okay, so then later on, if you want to add more rooms, then you can just simply change here. Okay, to make code more easy to be modified later. So this one, number of room I plus plus, then can replace this with rooms. Again, the way I write the name by using plural, because this is an array or a list. I dot draw. Okay, the same goes to number of ball, but this one is balls with I draw. Okay, as you can see later on, if I want to add more rooms or balls, I just simply change this part. I don't need to change here. Okay, however, this one we need to, okay, for this one, okay, this one we can use okay, because there is only two room here, so we can simply use, okay, loop here for room number one. Okay, how many we have? Two. Okay, here because we just want to replace this part. Okay? Plus plus, and then simply tag this, which is well, I think we don't have to do it in that way, because we simply write balls. Okay, balls 0, set room to room number 1. How to get room number 1? Okay, again, room number 1, again, you must specify a pointer here. Okay, you must specify a pointer. So again, last time I have mentioned this, in fact you learn from PT1, an array actually is a pointer. So you're supposed to be writing something like rooms, room 0, right? This is not a pointer. This is basically an object, because we reference the index, and then in order to get it's supposed to be something like the address of the first room. But this one, actually you can write with this one, room plus 0. Okay, that means the pointer for the first room, or simply room. Okay, so the same goes to room number 2. Okay, room, this is basically rooms plus 0. Okay, how about this room number 3? Because ball number 3. Okay, ball 2, you need to set to the second room, right? So it's supposed to be something like balls 1, and then put an address, make it as a pointer. Or this one is actually room plus 1. This is a pointer, but if you write this is an element, not a pointer, that means what is an element of a room is an object. But if you want to reference as a pointer, this is the syntax. Okay, so this is supposed to be done, and then since we have now we can conveniently rewrite this into a loop. Okay, I mentioned this, you can use loop here if you have this kind of, you just want to use something like this one in order to replace the repetitive b1 b2 b3, the we write in a loop. I less than number of for I plus plus, then we simply take false I. Okay, let's try first. Hopefully everything is fine, but if not, then we need to fix that later. Okay, we got a bunch of errors. Okay, so conversion from, okay, so yeah, I need to make it home. Yeah, again, where else? And then okay, just a tips, when you compile your code, okay, you got error, try to fix one by one. You don't try to fix everything, but you fix one part and then try to compile. Okay, try to compile, and then if you still get errors, then compile again for that error. Okay, oh yeah, we don't draw the, okay, what's wrong with this? Okay, let us double check. Okay, I think some typo here. So this one I need to remove one of it. Okay, this one's supposed to, okay, let me try to compile it again, because just now the second room doesn't show. Yeah, the second room is not his. Yeah, I think everything is working now. Okay, so actually this one you can modify further, or you can improve further, such that like this one, you can only test collision between balls, right? Because just now we just test the collision between balls and the wall. But as you can see here, suppose when these two balls, the circle, collide to each other, they're supposed to be bounce. Okay, so you can do that as well. So that one will introduce with another relationship between circle to circle, okay, or ball to ball. So for the sake of this tutorial, for simplicity of this tutorial, we don't go for that for now, but later on in your project you may want to implement that as well. Okay, I think that's all for this tutorial. I hope you have coded along, and then you learn something from this. Okay, again, I just want to remind you, this program basically is the template for you for doing your project. Okay, for doing your project, yeah, the structure is already there. You just need to add more classes, more objects in your project according to your game. Okay, I think that's all.